In this session, I'm going to talk about some of the complexities that come up when we look at special relativity closely. The first one of these is what's known as the twin paradox. And this paradox says if we had a pair of twins and one of them went off traveling around space at very high velocities, when he returned, although he would have aged, would the twin left on planet Earth have aged much further? So this is the twin paradox. Okay, so it thinks about this situation where we consider the issue of time dilation and when people travel at velocities close to that of the speed of light. So is this true? Well, for the twin paradox, if we consider the astronaut on the spaceship, there's some issues there. One issue would, shouldn't the astronaut also have been able to see Earth's time run slow compared to his or her clock? Potentially. But the overall answer is yes, because there's much more going on. For a start, the astronaut had to turn around, so couldn't constantly monitor time on planet Earth, and also thus accelerated. So if he was accelerating away, the astronaut was not in an inertial frame of reference. So therefore, the symmetry really breaks down, and reach goes beyond our limited understanding of this situation. But if the resolution to the paradox becomes mathematically complicated, the paradox is actually confirmed. Okay, so mathematicians out there have been able to confirm. However, the special theory of relativity deals only with inertial frames of reference. So the astronaut twin would have undergone huge accelerations, and therefore this idea falls down. However, I guess there is a however. Let's look at some time dilation examples, which are going to bring this into context. You and a friend are having a drinking contest. Your friend is on a train traveling at a speed of 0.9 times the speed of light. By her watch, she finished her drink in 5 seconds. To determine the time you measure if you are standing still at the station. So we'll use our time dilation formula, and this is the one which has got the Lorentz factor integrated in. Now, she measures her time, so her time is 5 seconds. And if we go through our process, the time which you observe is 11.5 seconds. So since drinking is happening on the train, that is the proper time. And you're observing the measurement as 11.5 seconds. Fair enough. So therefore, now it's your turn. Now, according to your watch, you finished the drink in 5 seconds, but how long does your friend think it took to finish? Now the drinking is happening at the station, so this is now the proper time. And therefore, in this case, your friend thinks you took 11.5 seconds. So in this case, both people think they won, because their time was 5 seconds, and it appeared that the other person had taken 11.5 seconds. So here's one of the quandaries, I guess. As long as the symmetry is maintained, then both people will perceive something else, and of course the twin paradox falls down because there's a requirement for them to accelerate away and accelerate back again. Hafeel and Keating created an experiment to try and demonstrate the twin paradox. So they got to a point where they had 2 atomic clocks, and they were flown around the world in opposite directions. Now what happened here, as they're traveling around the world in opposite directions, obviously the world rotates around as well. It means that they're going to have, should have, different relative speeds compared to a clock left on planet Earth. And that is exactly what happened. We found the eastward journey, time was lost, and the westward journey, time was gained. And we can see that there's some difference between predicted values and measured values, but definitely the direction of the change is in keeping with what was expected. So that means the experiment showed that the clocks had definitely experienced time dilation compared to a stationary clock. One clock had slowed up and one clock had slowed down and one clock had sped up. So although the twin paradox has some flaws in it, the idea of time dilation depending on a journey is true and has been proved by this experiment. Hopefully that gives you an insight into the twin paradox and some of the issues associated with considering special relativity at the extreme.